One of the great recent revolutions in our understanding of the universe is that most of the universe cannot be seen. We know that the universe we've studied and come to know via the great discoveries from Galileo through Einstein is only 5% of the universe. The other 95% consists of dark matter and dark energy. While astronomy has always been a particularly challenging field of study, trying to understand something we will never touch, never travel to, certainly never examine in a laboratory, the exploration of the dark universe seems to take these challenges to an entirely new level. How can we ever learn about things that live forever in the dark?
Einstein predicts that all matter in the universe will bend light. And so if you have huge aggregates of matter, you see a lot of light bending. And what you end up doing is that you correct for this distortion of light, and that actually allows you to figure out what the matter is that was doing the distorting. So you kind of map.
Dr. Priyamvada Natarajan, professor of astronomy and physics at Yale University, is an explorer who has taken on this daunting and exciting challenge. Dark matter would be utterly unknowable to us except for one factor: it does have gravity. This gravity and the dark matter responsible reveal themselves by bending and distorting light, a phenomenon called gravitational lensing. The ghostly way in which dark matter shapes the behavior of the seen universe gives clues to its existence in nature, and has enabled Dr. Natarajan to map the location of dark matter. Dr. Natarajan describes herself as a cosmic cartographer. She has always loved maps of all kinds. As a high school student in New Delhi, India, she used a Commodore 64 computer that her father gave her to create a star map of the night sky. Black holes are her métier. While a doctoral student at Trinity College in Cambridge, England in the late 1990s, she predicted the existence of a new kind of object in the universe: cosmic winds that were driven thousands of light years into space by a black hole and influenced distant star formation. 2 decades later, in 2019, her theory was validated when radio astronomers detected the very cosmic winds she had predicted. Lurking at the centers of all massive galaxies, including our Milky Way, are supermassive black holes, feeding on stars and gas unlucky enough to pass too close. Dr. Natarajan's work led her to theorize that, contrary to earlier theories, even these supermassive black holes cannot grow forever. Once they are as hefty as tens of billions of times the mass of our sun, they get so hot they drive away their starry food supply. Cosmologists have sometimes invoked hypothetical new particles called WIMPs and sterile neutrinos to explain what dark matter is, but these particles have not been detected. In December 2021, Natarajan and colleagues at the University of Miami and the European Space Agency offered a tantalizingly simpler explanation of dark matter that requires no new particles and no new physics. Building on work of the late Stephen Hawking, they proposed that dark matter and black holes are one and the same, and that all black holes were created in the earliest moments of the universe, immediately after the Big Bang 13.8 billion years ago. The powerful new James Webb Space Telescope, which is 6 times larger than the Hubble Space Telescope, should be able to detect primordial black holes if they exist. Dr. Natarajan's contributions to cosmology have been recognized around the world. The winner of a Guggenheim Fellowship and the India Abroad Foundation's Face of the Future Award, she was elected to the Royal Astronomical Society, the American Physical Society, and the Explorers Club. She was the Caroline Herschel Distinguished Visitor at the Space Telescope Science Institute in Baltimore. Today, she has academic appointments at both Yale and Harvard, holds the Sophie and Tycho Brahe Professorship at the Dark Cosmology Center of the Niels Bohr Institute at the University of Copenhagen, Denmark, and is Honorary Professor of Life at the University of Delhi. For tackling the most fundamental and most intriguing questions about the origin of the universe, tonight we are pleased to bestow on Dr. Natarajan Liberty Science Center's 2022 Genius Award.
Thank you so much. It is a real privilege and an honor for my work to be recognized, and I'm delighted that you are all here. I miss my parents who are in India who couldn't join us tremendously. I got my start, the love affair with the cosmos, in a place rather like the Liberty Science Center, not quite as wonderful. I wish I had this place when I was a young child. It was the Nehru Planetarium in Delhi. And I am so grateful for places like the Liberty Science Center that exist, that stoke the curiosity of young kids and show us the wonders of nature, be it the cosmos, be it the cell, and train us to stay open-minded, in awe of the natural world, and forever curious. So I am deeply grateful to all my colleagues, my students, the research teams that I work with across the globe, who over the years have contributed, and with their many, many gifts have made all of this possible. I also want to give a particular shout out to my mentors over the years, in particular that one person, Dr. Nirupma Raghavan at Delhi Planetarium, who really saw my future as a scientist, and as a scientist who could make all her dreams come true well before I did as a child. So we live in a world where science seems to be at siege. I really hope that places like the Liberty Science Center can reorient the world where it really needs to be, where every child, every grown-up becomes a child when they are here and are thrilled to discover, and the simple joy of figuring things out for yourself. So I'm really honored to be recognized, and thank you very much.
Thank you. Thank you.